Guys, check this thing out. You might be asking to yourself, what's so special about it? It's just a Sanwa 100mm dome button with a off-white light bulb. Well, as a matter of fact, what if I push it? Now it's red. And now it's green. And then it's blue. And then it's white again. What gives? So, on those Sanwa switches, the optical ones, you normally have 5 wires coming into it. Plus and minus that goes to the light bulb, and the 3 wires for the photocoupler switch. So you only have 2 wires going to the light bulb, and the light bulb is a standard kind of wedge type white bulb, which might also be not white depending on the application you're using it for. So how does this contraption work then, if it still has the same 5 wires? Oh, let me show it to you. If we take the dome off, you can see we have something in there that's glowing red now, and if I push the button, it changes colors, but we still have only 5 wires. And if we unplug this thing and bring it up closer, you can see instead of a light bulb we have a RGB LED and a small circuit board. And you can see the circuit board has plus and minus labeled on it, and otherwise it wedges in just like a standard light bulb, but it also has a diode and a capacitor on it. So the actual way that this works is pretty simple. Even though it's not very bright in this setup because it's a proof of concept, I cannot drive a fully fledged LED off of a Arduino pin after all. This is the whole circuit diagram, and as you can see, it's pretty darn simple. So we have the plus and minus wires coming in for the light bulb, and the plus then goes directly to the data input. But it also splits off through a diode with around something like 0.5 volts voltage drop. Anything more than that you would probably start having problems. And a tiny 10 microfarad tantalum cap goes across the VCC and ground of the LED module. So how this works is, when we first initialize the LED output on the Arduino in this case, we set it to high, which is gonna be plus 5 volts, and down here is 0. When we want to, say, transmit data at some later point in time, we switch it to 0, and we wait enough time for the LED to consider it a reset state. And then we just start, transmitting our data as usual, so whatever binary goes here. And this would be the voltage at the data input. But what happens on the VCC pin, it's going to actually be smoothed out by the capacitor. So when we have a 0 bit, it starts going down, but then it goes up again, and then it goes down and goes up again. So the LED never loses power technically, as long as you stay above like a certain threshold, which is not enough for the internal microcontroller of the LED to sustain itself. There's been numerous articles about this on the internet, and I'll link to them below, but it's not a very widespread tactic, in particular because you cannot really daisy chain those anymore because of the current draw implications. Though maybe that is possible if you add a buffer capacitor to each one of them. But then you have to have a really decent current supply on your data pin, maybe like a MOSFET buffer or something. But for now, as some of you may know, I am working on a Tap Tap Revenge arcade cabinet, and I wanted to use those little Sanwa switches in this. And so now I can actually do that without having to modify the switches for RGB LEDs or buying the more expensive, I'd say outrageously expensive Sanwa buttons that have RGB from the factory. In any case, thank you for watching, and I'll see you around.